Good morning, everyone. As she said, I work for the U.S. Army Corps of Engineers Engineering Research and Development Center, which is a bit of a mouthful. But you can kind of think of it as the Army Corps of Engineers National Research Lab. We build tools and we do research for other people in the Army Corps of Engineers, other people in the Department of Defense to do various things from building levees, modeling hurricanes, buying new tanks, buying new aircraft, all the design. We build a lot of the tools that the different organizations use across. And so I wanted to talk about some of my experiences. Quick show of hands, anyone here work for any kind of government entity? Okay, couple. Any of you work for large organizations? Okay, so some of what I say should cross over to a lot of this. So I'm going to be talking about how to use open technologies and why. And some background, I had about 5 years in a university research setting, doing algorithm development for numerical models, hydrodynamic models, hurricane research. Most of that time, everything I worked on was closed, mainly because none of us knew any better. And a lot of stuff written in Fortran and C++. We shared code with other researchers who were writing papers with us, but we didn't have GitHub back then, so there's no easy way to do it. We didn't really use version control. The idea of using open technologies wasn't really around. Spent 10 years in state government here in Texas, and there, that was where the transition happened. I'll talk a little bit more about that, but in state government, I was working for a natural resource agency, the Texas Water Development Board, and nothing we were doing was really secret or proprietary, but our workflow mainly used proprietary tools. It was just the way it had always been. And now I worked for the Army Corps of Engineers for the last couple of years, and now I'm in a situation where there are some things we do that we cannot release. We have export-restricted software, we have classified data sets. There's just some stuff that is never going to change. It's going to be closed. There's also the fact that these are all large organizations. I am not going to change Department of Defense policy on whether a piece of software is going to be export restricted or not. I'm not at the level where I can do things like that. So working within the constraints of the organization you're in becomes very important. In 2008, I was doing coastal ocean modeling, and my workflow went out. This is the Sabine Lake area near the Texas-Louisiana border. We went out, we collected data, went out on boats, we put instruments in, we collected a bunch of data. And we eventually had to come up with simulations of the ocean and to do some work related to how to protect the marshes in the area. And my workflow was a mix. We had Bash, Perl, Awk, SAD, C. The main engine was a Fortran code. Most of the big ocean models and atmospheric models are typically in Fortran. Some of them are in C++. And also we use a lot of proprietary tools. We use TechPlot, which is a software that came out of the aerospace industry that does 2D, 3D visualization. And ArcGIS is the big geospatial package, and then MATLAB was all our post-processing and what would you say, post-processing, plotting, all that kind of stuff. It worked. It was painful. It worked. And around this time in 2008 was when I hit the limits of this workflow, both individually and in the team we had at the agency. And this is what I'll say. I would call this workflow artisanal. It's handcrafted. Everything kind of works together. It is very fragile, and it's very prone to breaking. It's very prone to knowledge, employee knowledge, which disappears when someone leaves. There are scripts, some of the components of the workflow I was using were written by other people who had left the agency, and there was no documentation, there was no idea of why things were done a certain way. Was there a reason why we did this analysis this way, or was it just because that was the bash code or Perl code which was left behind? It broke very easily. And working with, where the workflow really broke down is I needed to move things in and out of multiple tools to get my final product. And the amount of friction moving in and out of those tools was tremendous. So my talk's supposed to be about how and why we should use open technologies, but I'm going to take a detour into why Python. Because, and you know, some of you guys have already heard this, there are long talks about why you should use Python for data science and engineering. I'm just going to go through a few brief things because in a sense, Python was my gateway drug into open technologies. I am not an open source zealot. I did not use open source because, you know, I read The Cathedral and the Bazaar and thought, oh, this is amazing. I mean, I do think it is a good idea, but that's not the reason why I used open technologies. So my workflow in 2008 transitioned to Python. I Googled around MATLAB replacements in 2008, and Python popped up. I tried it. 3 times in my career. So back when I was doing all this, everyone told me I was supposed to learn Java. If you wanted to have a good time with your future career, you need to learn Java. I tried to learn it a couple of times. It did not work. It just too dense. With Python, I could understand programs I read even when I didn't know the language. It had all the scientific languages I needed. I could interoperate with everything in my pipeline, in all parts of my pipeline, even putting things on the web, and the data structures and language features. And the last one, community support. When I was at the state agency, we were paying for commercial support on several of our products. And I used to call their helplines because we had paid support. I got better support from the open source community and the SciPy mailing list than I did from our paid support. Actually, if you Google my name on the SciPy mailing list around 2008 to 2012, I think it'll pop up almost every day, like, you know, how do I process time series data, stuff like that. The other thing is Python scales. And I'm not talking about scaling from one core to multiple cores or to a cluster. I'm talking about scaling on people. Because when I first learned Python, I used it as a procedural language, imperative. Just do this, do this, do this. I used it as a scripting language. As I learned more, I started using its object-oriented features. As I learned more, I started using its deeper features. It scales because you can have people at all levels in your organization using it and being able to transition along the line of becoming more and more of an expert. I like it because easy things are easy. Print hello world is basically print hello world. Complex things are sensible, and hard things are possible. It's not the best language for any particular thing. You know, if you pick something, functional programming, it's not the best language for functional programming, but you can do it. So it gives you a single place you can do everything. And I really like this last statement. It's optimized for human productivity. And we'll get to this again, because human productivity, people are your bottleneck in any organization. Your bottleneck is not your HPC system or how many cores you have on your computer, or you know, how many instances you can throw up on AWS. It is how the people in your organization can understand and do analysis and move tools. So why do I pitch open technologies in my organization and in my work now? It's because I can get the job done. I can get it done faster, I can get it done quicker, I can get it done cheaper, and in a much more effective manner. And it's not just that it's open, and this is why I went back to the Python thing. It's that it's open, that it's a people-productive environment, that you can sit someone down, you can sit a new employee down, you can sit someone with not much training or a lot of training in another field and get them up to speed really quickly. And you can have low friction into new technologies. most of our organizations have these closed ecosystems, and there are reasons for it. I mean, I work for the Army now, and we have stuff that's restricted. It's not going to be put on GitHub because there are laws. If we put it on GitHub, I will get arrested. There is stuff that is not going to be out there. But whenever you have a closed ecosystem, you have limited staff, limited time, funding, and most importantly, expertise. My organization mostly hires computer scientists, civil engineers, other types of engineers. We don't have people who are experts in data science. We don't have someone who could, pick up image processing and build a whole library. We don't have those people. So collectively in our organizations, we need to stop building our own stuff and start using stuff other people built. I'm going to take a slight detour about licensing, and this is the other reason for open, is for me, at the state and at the federal level, licensing impacts me a lot. Because this happened at my previous job. I wanted to try neural networks for a project I was working on. Oh, okay, the neural network toolkit in MATLAB is an extra $1,500. Okay, that's not a big problem, we have it in our budget. The contracting paperwork to buy that license is going to take 3 to 6 months. I am not going to try to use that new neural network to solve my problem because I cannot do it quickly. Buying software impacts my development speed, it impacts my ability to try new things, it impacts deployment. Now I've got something working really nicely, I want to put it on the server. Oh, I need another license on the server. Oh, okay, that license is per core. So if I want to run a multi-core system, now I have to get multiple licenses. If I want to spin up new servers, I have to get multiple licenses. It's friction that slows things down. I have nothing against proprietary tools. They just stop me from getting my work done. If you're in an organization that lets you buy things really easily, this might not matter. But even then, I would move away from proprietary tools, and definitely tools that keep your data hostage. The amount of resources, so unless you're Google and you can build TensorFlow internally, your internal resources cannot match the open data science community. Your ability to build a machine learning toolkit internally or a platform internally, you have a team for a project, I don't know, maybe 5 to 10 people working on a project, maybe more, maybe it's 20. That team has varied expertise. You have people from different backgrounds. They are not going to match the people you have in the data science community. The stuff coming out of Pandas, out of Jupyter Notebooks, Jupyter Lab, the number of people working on those things and the expertise they have in those domains, your internal teams are not going to match them. And in most cases, neither can commercial vendors. The open source geospatial community is iterating and moving way faster than the commercial vendors, and they're solving harder problems. You need to be building a layer on top of the open ecosystem, because your internal software needs to try and push as much stuff as it can outside of your organization. Because if you don't, you own that puppy. If you build something, you're the one building it, you're the one maintaining it, you're the one making sure it keeps going. And this is very difficult in today's day and age with people moving jobs and institutional knowledge disappearing. So as much as you can, you really need to get things out of your organization. There are risks involved. I don't know if you saw this news article last year. Someone unpublished a JavaScript library, 17 lines of code on NPM, and broke a large swath of the internet because people were using it without thinking about why they were using it. So be very selective when you use open technologies. I have, I'm not going to go into all these. I can talk more, but there is a criteria you need to do. Don't just pick every open technology out there. See what makes sense, how many people are using it. I'll just pick on one, Python 3. If you're picking a software to use in your stack which doesn't have Python 3 compatibility, in 3 years, you're in trouble when it end of life. I'm low on time, so I won't go in this. If you want to talk about it, we can talk about it later. Packaging is hard. A large portion of my career has been dealing with compiling and building and packaging a geospatial software called GDAL on all 3 platforms. Before I found Conda, that was a pain. We now have a system. There's a whole bunch of packages which come in the Anaconda distribution. We use conda-forge for community packages, and there's other packages we need, which are open source. We build the recipes, put them on conda-forge, they get deployed on the conda-forge channel on the Anaconda website. And then we have internal, secret, and export classified software that we build, and we just host them on an internal server. We build conda packages, we put them there. People can just do conda install -c and use these channel names. It works very well. If you have code, should you make it internal? If you have internal code. If you're starting from scratch and you're building a new product, offload as much as you can to external packages. Or if you need a new feature, contribute to pandas or something and build that out there, because you don't have to own it. Internally, there's code we are trying to push to make external. There are issues. First of all, making something open source doesn't magically get you hundreds of contributors. It might, if you're solving a problem other people need solved. And in some cases, I have a small open source package that has a reasonable number of users, but only 1 or 2 people contribute to it, and it's fairly minor. But it's a useful package. Making internal code open takes effort. You might have to refactor and clean out, pull out dependencies that are intertwined with other stuff. You're probably going to have to do some documentation. Where I am, you have to do legal review, make sure you're not putting stuff out that's export restricted. You really need tests and continuous integration, because you get to the next part. If you're actually open sourcing a part of your structure, there's a social contract. You want other people to contribute to it. You want to make it available for other people. They're going to want to do stuff. They're going to expect some level of responsiveness when they ask questions about the code. It takes effort, but it also gains you open infrastructure. And this is the thing. We spent a year trying to get continuous integration working on our internal servers. We just got it done last week, and it's still not working on OS X. The parts of our code that's open source, I can stick it on Circle CI, AppWay, or Travis CI, and in 10 minutes, I can have it running on continuous integration. So there are things which become, if you're a government entity, there are things which become easier when parts of your code base are open source. A lot of these steps take work, and in some cases, it doesn't make sense to make your code open. But in a lot of cases, these are the same steps you need to take to make, if you're in a large organization and you want other departments to use your code, you better have documentation. You better have tests and continuous integration if people are submitting code back to you. So these are the same steps you need to make a better, more productive, more sustainable code base. So when it makes sense, I would highly encourage pushing things out and concentrating on what your company needs to concentrate on, because you don't want to own this big farm of puppies, which you then have to take care of. I think the next slide is the last one. I'm going to make one more point. The reason why, so I'm at my previous job at the state agency and now at the federal government, I'm in an organization that is suspicious and doesn't understand open source technologies. The reason that's changing, the reason I have freedom to use the things I use, is my productivity and my ability to get stuff done is order of magnitude higher than other projects. When I started at the federal agency I worked at several years ago, I was told to write a web scraper to get environmental data in C++, and I kind of said, no, I'm not going to do that. And I wrote it in Python. And my Python component was supposed to be a small part of this whole thing, and it's now morphed into the main backend API of the entire system, because the C++ component is still lagging in development because it's so hard to build in C++. Whereas I've gone through 3 refactors and 3 rewrites with lessons learned in the same time. So The reason open technologies are making leeway is you get stuff done, and you get stuff done faster. So with that, I'll close, and I'll take questions. Go ahead. I had a 3-year fight with our IT department because I said that we were, one of our new projects, we were going to use PostgreSQL, and they said that we had to use MS SQL. And none of our tools worked with MS SQL. And we had a Linux, they also said all our code had to be written in C#. And we said, we have a Linux server, C# doesn't run on that. And they're like, wait, you have a Linux server? I'm like, yes, it's in your data center. Anyway, the two parts of it is, one, there is opposition, and there was a level of us having to show proof that what we did wasn't crazy. Like, I had to prove that Python was a language Google and Microsoft used, because they had never heard of it. The second part of it was, it gets back to the reason I made leeway is, on the other side, you know, I was having a fight with the IT departments, but on the other side, my management structure was seeing the results of what we were doing. So the things we were pushing out faster than the IT projects and more effective and serving more people. So, but there is fear, and you know, you have to walk through that. You have to kind of talk their language and say, you know, I had to basically say we're using agile development because they wanted a label to what we're doing, because they're used to waterfall. Once I put the name agile development on our project, they were comfortable because we had a process, even though. So you have to talk their language, you have to show that what you're doing is effective. Someone over there had a question.
Thank you for this talk. It's really relevant to, I'm part of a team of about 4 people in an organization of 2,000, and we're looking to kind of build this open source data analytics platform in our company. So you've talked a lot about kind of using your results to show how much better this approach is, but do you have any other advice for sort of building a grassroots open data science platform in a established organization?
So the way I did it at my previous job and this job was mentoring people one-on-one, in a sense, because someone in my group was doing something, and I'm like, hey, look, here's how you can do it in like a third of the time using these technologies. And that's kind of how it grew. And then I got appointed to a position where I was helping make those decisions about that. So it's an for a situation like yours, it's showing them. I mean, if you take someone who's done analysis in Excel all the time and you show them pandas and you do a pivot table in pandas, they're usually shocked because they're not used. Or if you're dealing with time series data at all and you show them pandas, they're usually shocked because dealing with time series data is horrendous outside of a tool like pandas. So helping other people get their jobs done quickly and effectively is how you grow the group in your agency or entity. Any other questions? Okay, so the bus factor is how many people have to get hit by a bus before you don't have any developers for that software. One of my colleagues actually says he likes to use the word lottery, like, and I put code complexity in there too because there's 2 parts of it. I am not worried about including pandas as a dependency of my code base. That is a huge project, very well-established ecosystem. It's not going to go away tomorrow. There's other code that is run by one developer, and the last update was 6 months ago. Now with that, I really have to think about whether I want that to be a critical part of my ecosystem. But that's where the code complexity comes, because sometimes I will include that because it's simple enough that I can replace it or I can take over that code. But if it's a large chunk and it's a complex piece, and it's only got 1 or 2 active developers and they haven't made commits in a while, I will not use that even though it will help me in the short term. This is kind of like avoiding technical debt. In the short term, it gives me the ability to do stuff, but in the long term, now I'm stuck with this unmaintainable software.